Hello everyone, my name is John West, and in this presentation I'll be demonstrating how to analyze wireless network traffic using Wireshark. I'll be examining two different IEEE 802.11 data frames from the provided packet capture file. The first is an unencrypted wireless data frame, and the second is an encrypted wireless data frame. Along the way, I'll be explaining how the data link, network, transport, and application layers work together to transmit data across the wireless network. The OSI model overview. These are the physical hardware addresses used by the data link layer, which is layer 2 of the OSI model. The MAC addresses identify devices on the local wireless network. Wireless access point and switches use these addresses to deliver frames to the correct device within the same local network segment. The presentation objectives. The network layer, or the layer 3, uses IP addresses to identify devices across different networks, unlike the MAC addresses, which only works locally. IP addresses allow routers to forward packets between different networks until they reach their final destination. The frame 8 unencrypted frame. The transport layer provides an end-to-end communication between applications. The TCP uses port numbers to identify which application is sending or receiving data. It also provides reliable communication by using acknowledgement, sequencing, and error recovery. Layer 2, which is the MAC addresses. This is the application data being transmitted. Because this wireless frame is unencrypted, anyone capturing the traffic can read the information directly. This demonstrates why transmitting sensitive information without encryption is significantly a security risk. Layer 3 and layer 4. This is the application data being transmitted. Because these wireless frames is unencrypted, anyone capturing such traffic can read the information directly. This demonstrates why transmitting sensitive information without encryption is a significant security risk. On the part of layer 7, which is the application data, even though the wireless frame is encrypted, the MAC addresses remain visible because they are required for the wireless devices and access point to deliver the frame correctly across the local network. The frame 136, which is the encrypted frame. Normally, after the IEEE 802.11 header, Wireshark would decode the IP header and the TCP header as well. However, because this frame is encrypted using wireless security such as the WPA2 or the WPA3, the payload cannot be decrypted without the proper encryption keys, which is as a result of the process involved. Since Wireshark cannot decrypt the payload, it cannot display the IP addresses, the TCP ports, or the application data, which are contained inside the frame. Encrypted frame analysis. The remaining payload appears as encrypted or scrambled data. Encryption protects the confidentiality of users' information while it transmits across the wireless network. Even if an attacker captured these frames, the information cannot be read without a correct encryption key. In conclusion, This packet capture demonstrates the differences between unencrypted and encrypted wireless communications. In the unencrypted frame, we can clearly observe the MAC addresses, IP addresses, TCP ports, and the application data. In the encrypted frame, only the layer 2 information remains visible, while the upper layer information is protected through encryption. Understanding how Wireshark display traffic at each OSI layer is an important key for network administrators and cybersecurity professionals, because it helps with troubleshooting network optimization and security analysis. Thanks for watching.